Hello students, today in this video we will see how to solve the numericals for the Maclaurin's theorem. Rather we'll see how to expand the given function by Maclaurin's theorem. For that we will use three different types of methods. The first method is use of the standard expansions. We have seen a list of standard expansions in the previous video. The second method is use of differentiation and integration. And the third method is use of substitutions. So first we will see how to use the standard expansions and solve the numericals. Now we have been given to expand, or rather we are asked to expand 1 plus x bracket raised to x in ascending powers of x up to fifth power of x. That is, we have to expand this 1 plus x bracket raised to x up to x raised to 5. We don't want the terms beyond that. We want terms up to x raised to 5. So let's proceed. Let y be equal to this given function 1 plus x bracket raised to x. Now we will take logs on both sides. So what we will have is log y is equal to log of 1 plus x bracket raised to x, which will be x into log of 1 plus x by the rules of logarithm. This can be further written as x into. Now this log of 1 plus x, this term, we have a standard expansion for log of 1 plus x, and that we have seen in the previous video. We know that. So for this log of 1 plus x, we will substitute the standard expansion. So what we have is x into. The expansion for log of 1 plus x is x minus x square by 2 plus x cube by 3 minus x raised to 4 by 4 plus x raised to 5 upon 5 and so on. This can be further simplified and we have it as x square minus x cube by 2 plus x raised to 4 by 3 minus x raised to 5 by 4 plus x raised to 6 by 5 and so on. And we'll say this equal to z. We'll consider this as z. So what we have, log y. This is nothing but log y. This log y is equal to z. So y will be e raised to z. And now for this e raised to z, we have the standard expansion, the exponential series. So for this e raised to z, we will substitute the standard expansion. It will be in terms of z because we have e raised to z. So it is 1 plus z square upon 2 factorial plus z cube upon 3 factorial plus so on. It will continue. And now in the next step, for this z, we will substitute in terms of x because z was this. For this whole term, we have taken it as z. So what we have is 1 plus z. We'll substitute this. X square minus x cube by 2 plus x raised to 4 by 3 minus x raised to 5 by 4 and so on. Then we have this term, it is z square upon 2 factorial, that is z square by 2. So this can be written as plus 1 by 2 and this z square can be written as this whole term in a bracket and square of that. We have x square minus x cube by 2 plus x raised to 4 by 3 and so on in a bracket and square of it. Then the next term we have is plus z cube upon 3 factorial. It is z cube upon 6. So this can be written as plus 1 by 6, and for z we will substitute this. It will be x square minus x cube by 2 plus, it will continue in a bracket, raised to 3. Now you can see here in this particular step, we have taken terms in this bracket. We have taken up to x raised to 4. Here we have taken up to x raised to 3 only, because here it is bracket raised to 3, here it is bracket raised to 2. And what we want is the expansion up to 5th power of x. We don't want the terms with higher powers of x. So we are taking the terms only up to this. Here it is x raised to 4 by 3. Here it will be x cube by 2. Because here it is square of the bracket. Here it is cube of the bracket. Now we will simplify it. We'll neglect the terms for x raised to 6 and higher powers of x. And what we get is y is equal to, it will be 1 plus x square minus x cube by 2 plus x raised to 4 by 3 minus x raised to 5 upon 4, plus from the next bracket we are taking only these two terms, 1 by 2 into x raised to 4 minus x raised to 5. Then we don't have any other terms up to x raised to 5. They are of higher powers of x, and we will neglect those terms. And this can be further simplified. And what we have is 1 plus x square minus 1 by 2 x cube. Now here it is x raised to 4 by 3, and here it will be x raised to 4 upon 2. On simplification, we have it as 5 by 6 x raised to 4. And this term we have minus 1 by 4 into x raised to 5. And here it will be minus 1 by 2 x raised to 5. Which on simplification gives minus 3 by 4 x raised to 5. And this is the required expansion. The expansion was asked only up to this x raised to 5. Now we will see yet another example. We have been asked to show that e raised to x cos x is equal to 1 plus x square by 2 minus x cube by 3 minus 11x raised to 4 upon 24 plus so on. Now we will solve this. This x cos x, we'll consider it as y. So e raised to x cos x, it can be written as e raised to y. We are simplifying the given function so that we can use the standard expansions for solving the numerical, and it becomes easier to solve. Now this is e raised to y. Now for e raised to y, we have a standard expansion. So for e raised to y, we will substitute that expansion, and we will have it as 1 plus y square upon 2 factorial plus y cube upon 3 factorial plus y raised to 4 upon 4 factorial plus it will continue. Now in the next step, we will simplify this. What we are doing, this 1, it is as it is. Now what is this y? Y is nothing but x cos x. So for y, what we will substitute? X cos x, but x into this cos x won't be written as cos x. We will substitute the standard expansion for cos x in place of cos x. So this y, which is x cos x, can be written as x into the expansion of cos x is 1 minus x square by 2 plus x raised to 4 upon 24 plus it will continue. The next term, it is plus y square upon 2 factorial. It will be y square upon 2. So what is y? It is x cos x. So it will be x square cos square x. So what we will have for this term? We have x square upon 2. And for cos square x, we will substitute the standard expansion for cos x and square of that. So we will have 1 minus x square by 2 plus. It will continue. This in the bracket, square of that. Then the next term is y cube upon 3 factorial. So 3 factorial is 6. Y cube will be x cube cos cube x. So we have it as x cube upon 6, and cos cube x, we will have the series for cos x raised to 3. We have 1 minus x square by 2 plus. It will continue. Then this term, it is y raised to 4 upon 4 factorial. So 4 factorial is 24 and y raised to 4 is x raised to 4 cos raised to 4x. And for cos x, we are writing this expansion for cos x in a bracket raised to 4. And this will continue. Now you can see in this step, we have taken the terms here. For now here it is bracket raised to 2, bracket raised to 3 and bracket raised to 4. We have taken terms only up to x square. We have not taken the terms beyond that. Because what has been asked to show the expression, it contains term up to x raised to 4. We don't want terms beyond that, that is from x raised to 5 onwards. So we are taking terms only up to x square, because here we have bracket raised to 2, bracket raised to 3 and bracket raised to 4. So on simplifying, we will get the terms with higher powers of x. And now we will simplify this. What we have is 1 plus x into 1 is x minus x into x square by 2. It is minus x cube by 2. Now x into this x raised to 4, it will be x raised to 5 and we don't want that term. So we are neglecting the terms beyond that. Then here it will be plus x square by 2. And now it is bracket raised to 2. So which terms we are taking? The first term, square of the first term, it is 1. If we take these two terms, the middle term will be 2 into 1 into minus x square by 2. So 2 and 2 will get cancelled and what we have is minus x square. If we take a term beyond this, the power of x will be more than 4 and we don't require that term. So we are taking only these two terms. Now for this next term, it is x cube by 6 into this bracket raised to 3. We are taking the first term 1 raised to 3, it will be 1. And the terms beyond this, they will have higher powers of x. And so we are neglecting those terms. Then for this term, it is x raised to 4 upon 24 into 1 raised to 4, it is 1. Again, the terms beyond this, they will be of higher powers of x and we are neglecting those terms. And now we will simplify this. So what we have is 1 plus x minus x cube by 2 plus x square by 2 minus x raised to 4 upon 2 plus x cube by 6 plus x raised to 4 upon 24 plus it will continue. This will be 1 plus x square by 2. Now it will take together terms of the same power of x. It will be minus x cube by 2 plus x cube by 6 minus x raised to 4 by 2 plus x raised to 4 upon 24 plus and so on. And now we will simplify it. And we have 1 plus x. These two terms we have plus x square by 2. This term we have x square by 2. Then we have x cube minus x cube by 2 plus x cube by 6. We have it as minus x cube by 3. And these two terms on simplification give minus 11 upon 24 x raised to 4 plus. It will continue. And this is the required expansion. This is what has been asked us to prove. Thank you.